All right, for the next few minutes, I want you to think like an architect. We're going to take a simple mathematical blueprint and transform it into a really elegant, beautiful structure. Let's get started.
Really think about that for a second, because the shape we're about to build isn't just some random line. We're actually creating one of the most fundamental and, honestly, beautiful curves in nature, the parabola. So let's treat this less like a math problem and more like a creative project.
Every great structure starts with a plan. For us, that plan is the quadratic equation. This is the master blueprint. It contains every single instruction we need to build our curve perfectly. So our first job, it's learning how to read it. And here it is. Y equals ax squared plus bx plus c. This is the universal code. Anytime, and I mean anytime, you see an equation in this format, you know for a fact that you're looking at the blueprint for a parabola. No exceptions. It's a really powerful piece of info to have. Okay, so before we even think about plotting a single point, we can learn a whole lot just by looking at that very first number, the value of a. This one little coefficient tells us the entire orientation of our final design. It's the first and most critical instruction in the whole plan. And the instruction it gives us? It's incredibly simple. If a is a positive number, the parabola opens upwards. You can think of it like a smile. If a is negative, it opens downwards, like a frown. Right away, this gives us a huge visual clue about what our curve is going to look like. Okay, so we know the basic shape. Now it's time to survey our plot. Just like a builder, we need to find the specific critical points that are going to anchor our parabola in place. These are our landmarks, the intercepts, and most importantly, the vertex. And for our project today, this is the specific blueprint we'll be working from. Y equals x squared minus 4x plus 3. From this one simple line of code, we are going to construct our entire curve piece by piece. Here's our construction schedule, a clear 4-step game plan. First, we'll find where our curve crosses the horizontal x-axis, then the vertical y-axis. After that, we locate the crucial turning point, the vertex, and finally, we just connect everything to reveal our finished design. All right, let's get to it. Step 1, the x-intercepts. Now to find where the curve hits the ground, so to speak, we just set y to 0. That gives us x squared minus 4x plus 3 equals 0. To solve this, we just need to factor it. We're looking for two numbers that multiply to positive 3 but add up to negative 4. And that's got to be negative 1 and negative 3. So our equation becomes x minus 1, x minus 3 equals 0. Now, for that equation to be true, one of those parts has to be 0. So if x minus 1 equals 0, then our first solution is x equals 1.
And if x minus 3 equals 0, then our second solution is x equals 3. And just like that, boom, we have our two x-intercepts. These are the first key landmarks for our design.
All right, let's move on to our next landmark. Step 2 is finding the y-intercept. And trust me, this one is even easier. To find where the curve crosses the vertical axis, all we have to do is set x to 0. And in our blueprint, if x is 0, those first two terms just vanish, and we're left with just y equals 3. That's it. So our parabola is going to cross the y-axis at the coordinate 0, 3. Another key landmark is now officially on our map. Okay, now for the most important landmark of all, the vertex. This is the absolute turning point of the curve. And because a parabola is perfectly symmetrical, the vertex always lies on something called the axis of symmetry, a vertical line that's exactly halfway between our two x-intercepts. We find it with the formula x equals negative b over 2a. So for us, that's negative 4, which is positive 4, divided by 2 times 1, which gives us x equals 2. So we know the center line is at x equals 2. Now we just plug that value back into our original blueprint to find the y-coordinate. So y equals 2 squared minus 4 times 2 plus 3. Let's see, that's 4 minus 8, which is negative 4, plus 3, which gives us y equals negative 1. And there we have it, the absolute minimum point of our parabola, the very bottom of the curve, is located precisely at the coordinates 2, negative 1. This right here is the cornerstone of our entire design. Okay, the survey is complete. We have all our landmarks, our key coordinates are all mapped out, and that means it's time for the most satisfying part of the job, bringing this blueprint to life and actually sketching out the final design. All right, so let's just do a quick recap of the critical landmarks we've found, the foundational points of our structure. We've got our x-intercepts at 1, 0 and 3, 0.
We've got our y-intercept up at 0, 3, and we've got the cornerstone of the whole thing, the vertex, down at 2, -1. With these 4 points plotted on the graph, you can already start to see the elegant shape of our curve beginning to emerge. But just drawing the curve isn't the end of the story. Now we get to do the cool part. Step back, admire our work, and understand the secrets that this beautiful shape holds. What if we actually built here? This is that final moment. All we have to do now is connect our 4 landmarks with a smooth, symmetrical curve. And just like that, from one simple little equation, a perfect parabola emerges. Our architectural project is officially complete. So what's the big takeaway here? We've created this predictable, symmetrical curve. We know for a fact that its absolute lowest point, its minimum value, is defined by that vertex at 2, -1. And we've confirmed it's perfectly balanced on either side of its axis of symmetry. See, it's not just a drawing. It's a whole system with predictable, reliable properties. I really love this because it gets right to the core of why this stuff matters. The vertex isn't just another coordinate. It's the heart of the parabola. In the real world, this point could represent the lowest possible cost for a company, the highest possible profit, or the maximum height of a launched rocket. It's the point of optimization, which is what so much of science and business is all about. And that's what makes this so fascinating, right? We've just drawn one, but this exact shape is coded into the fabric of physics and engineering. It's in the curve of a satellite dish focusing signals, the cables of a suspension bridge distributing weight, the flight path of a thrown baseball. It really makes you wonder, what other secrets is this simple curve hiding all around us in plain sight?